Alright, this is the third video on lesson 5.4.2. If you haven't watched the other two, you should do those first and then come back to this one. Now we're moving on to example 5. Horizontal asymptote. I'm going to have to think about multiplying this out. If I multiplied out the numerator, I would have x squared plus 2x and some other things. I don't need to worry about that for the horizontal asymptote though. I just need the first term so I know the degree. Here the numerator has a degree of 2. In the denominator I have x plus 2, so my degree is 1. That means this function is top heavy, so there is no horizontal asymptote. It has an oblique or slant asymptote instead. Alright, we can move on to vertical asymptotes. When we're thinking about vertical asymptotes, we have to make sure we've simplified our function first. So going back to it, we have x plus 2 divided by x plus 2. That cancels out. That just leaves x minus, let's try this again. The simplified function is just x minus 1. That's it, x minus 1. So there's no vertical asymptote. The denominator disappears when we cancel x plus 2, so there's no vertical asymptote. There is, however, a hole. I have to think about x plus 2 for my hole. So my hole will be at x equals negative 2. Let's plug negative 2 in to the simplified function. So we have y equals, x minus 1 is the simplified function, so we have y equals negative 2 minus 1. So our y value is negative 3. So my hole is at negative 2, 3. So let's plot that hole. Negative 2, 3. Oh, come on now. There we go. Woo! Made that a little too big. Okay. Negative 2, 3. That's better. Alright, let's do the x-intercept. Remember, for x-intercept, we set y equal to 0, or the shortcut is just the numerator. So 0 equals x plus 2. Alright. Oh, not x plus 2, sorry. 0 equals x minus 1. That leads me to think that the x-intercept is at 1. Alright, so we can go over to our graph and plot an x-intercept at x equals 1. Let's do the y-intercept. For the y-intercept, we set x equal to 0. And we can do it with the simplified function. So we have y equals x minus 1. But change that x to a 0. So it's negative 1. So our y-intercept is at y equals negative 1. Or 0, negative 1. Alright, so let's plot that. 0, oops, move the screen. We're at 0, negative 1. My graph looks a little funny. I just realized why. My hole was at negative 2. I said it was at 3, but it's at negative 2, negative 3. So add that negative. Let's move that hole. So it should be at negative 2, negative 3. There we go. Negative 2, negative 3. Okay, so I have 2 points on my graph. I have no vertical asymptotes, no horizontal asymptotes. Let's go back to thinking about this function. The simplified function was y equals x minus 1. Y equals x minus 1 is a linear function. So it has a slope of 1. It goes through these points and continues on. There's a hole, but then after that, it continues on with a slope of 1. So this is technically a rational function, but because of the way it's simplified, it ends up looking like a linear function, but with a hole in it. So that is example 5. We don't need to test any points, but if you want to find other points for the graph, you can. Let's go back now to example 1, the final example. We haven't done that one yet. Okay, so we're back at example 1. Graph f of x equals 2x squared plus 5 over x squared minus 25. Let's factor this right away. The top doesn't factor, so we have 2x squared plus 5 over x minus 5, x plus 5. Alright, now we can start thinking about the different parts. Horizontal asymptote. Need to look at the degree in the numerator and denominator. It's balanced, it's degree 2 for both, so I have to look at the numbers in front of the variable. So I have 2 and an invisible 1. So this is 2 over 1, or just y equals 2. So let's put that horizontal asymptote in there. And y equals 2. Vertical asymptotes. Well, looking at this function, I actually have 2 because neither of these cancel out with the numerator. So I have a vertical asymptote at x equals 5 because of this factor here. If I set it equal to 0, I get x equals 5. The second factor here gives me a vertical asymptote at negative 5. Okay, so because we can't cross vertical asymptotes, I'm going to do this in bright orange. We have a vertical asymptote at 5, and we have a vertical asymptote at negative 5. Okay, so we actually have 3 sections to our graph now. We have left, middle, and right. So it's starting to get interesting. Do we have any holes? Well, there aren't any factors that cancel, so we can write none, or NA. X-intercepts. We find x-intercepts by setting y equal to 0, and the shortcut is making the numerator equal to 0. So 0 equals 2x squared plus 5. Subtract 5 from both sides. 2x squared. So I get negative 5 over 2 equals x squared. If I take the square root here, I get an imaginary x value. If the x value is imaginary, it can't be an x-intercept. It doesn't show up on the graph as a 0. So that's to say, all of this, there is no x-intercept. Alright, let's try the y-intercept. For the y-intercept, we set, separate this, we set x equal to 0. So f of 0 equals 2 times 0 plus 5 over 0 minus 5, it's a minus, times 0 plus 5. We get 5 in the numerator, we get negative 25 in the denominator. That's roughly, or as a decimal, it's negative 0.2. Negative 0.2. Okay, so let's plot negative 0.2 as our y-intercept. That is a value we have to hit. There we go. Right underneath the origin. Okay, for our graph, on the left-hand side, our graph either has to go up top or it has to go below the horizontal asymptote. If it goes below, you create a new x-intercept, but we don't have any x-intercepts, so this part here cannot be correct. Instead, it has to be the one up top. So let's erase these and make it look a little nicer. We have to hug the vertical and horizontal asymptotes. Whoop. Went too far. There we go. Hug the vertical and horizontal asymptote. Let's look at the right-hand side. I could be up top or below, but if I'm below, it creates a new x-intercept, one that we don't have. So I have to be above the horizontal asymptote again. Alright, so the question is, what happens here in the middle? That is the question. Okay. There are a few options. I'm actually going to scroll down to these other graphs so we can think about them. We had a vertical asymptotes at -5 and +5, and a horizontal asymptote at 2. The key thing to remember about horizontal asymptotes, I'm plotting the y-intercept right now too. The key thing to remember about horizontal asymptotes is they tell you about the ends, what's happening as you go to infinity and negative infinity. They don't actually tell you what's happening in the middle. So you can erase it if there's a middle section, or choose to ignore it in the middle. So now our graph could start down here hugging the vertical asymptote and go through this point and continue up towards our other vertical asymptote. But if it does that, we've created a new x-intercept, and we don't have any x-intercepts. So that can't be right. So the green one doesn't work. Let's think about purple. Sometimes rational graphs will look like this, curving down, but again, that creates a new x-intercept, one that we don't have. So that does not work. What we have to do is hug the vertical asymptote, I'm doing this in gray now, come up to the y-intercept, and then come back down. And this has gotten a little messy, so I'm going to clean this up here. We said that the green and purple graphs did not work because they created x-intercepts that did not exist. So let's draw our y-intercept back in. Alright, our graph is going to hug the vertical asymptote, come up, touch the y-intercept, and come back down hugging the vertical asymptote. It can't be up above because if it was, it wouldn't touch the y-intercept, and it has to go through that point. So this is what the bottom of our graph looks like. So let's bring that up to our graph above, and we can plot it. There we go. That is our finished rational graph. Now let's say I was struggling. I could actually test points here to figure out what's happening in this middle section here and what's happening in the middle section over here. So I could have plotted I could have found the value when x equals -3 and when x equals +3 and plotted those points. That could have helped me. So if you get stuck, you can always do that. Alright, that concludes the videos about how to graph rational functions. We'll work on the practice problems in class on Monday unless you want to get a start on this packet ahead of time.